Hello everybody, I hope you all are fine. So, what interesting topic are we learning today? Let's learn about glycolytic reaction steps or glycolysis. It's also called as Embden Meyerhof pathway for his contribution towards glycolysis. So, glycolysis is a metabolic pathway which occurs in the cell. It is the first step in the cellular respiration. It consumes 2 ATP molecule during this process to produce 4 ATP, 2 NADH and 2 pyruvate per glucose molecule. The pyruvate enters the citric acid cycle because it's the precursor. Now, glycolysis happens in 10 steps, where the first 5 steps involves glucose conversion into glyceraldehyde 3-phosphate. The remaining 5 steps includes where glyceraldehyde 3-phosphate is converted to pyruvate. So, let me explain this complete glycolysis in 10 steps for you people for better understanding. Kindly follow this carefully. Let's start. The glycolytic reaction step consists of 10 steps where we can divide the first 5 steps in which glucose is producing glyceraldehyde 3-phosphate. The first 5 steps involves where the glucose is broken down to produce glyceraldehyde 3-phosphate. So let's see the first 5 steps. The first step includes where glucose molecule consumes an ATP molecule to produce glucose 6-phosphate plus ADP. So the phosphate molecule from the ATP, one of them, is used by glucose to produce glucose 6-phosphate plus ADP. ADP is nothing but adenosine diphosphate. Your ATP is nothing but adenosine triphosphate. So this glucose 6-phosphate gets into the next reaction step where glucose 6-phosphate it's converted to fructose 6-phosphate. Alright, where glucose 6-phosphate is converted to fructose 6-phosphate. Now, this is a reversible reaction. Alright, the first step is a unidirectional reaction, but the second reaction is bidirectional. That is, fructose 6-phosphate can get converted back to glucose 6-phosphate also. So you put a double-sided arrow. So the fructose 6-phosphate consumes an ATP molecule to produce fructose 1,6-bisphosphate plus ADP. Means a phosphate molecule from here is consumed by fructose 6-phosphate to produce fructose bisphosphate plus ADP. This 1,6 will show you the region where the phosphate molecule is attached to the fructose. The fourth step would be fructose 1,6-bisphosphate gets converted to dihydroxy acetone phosphate, okay, and glyceraldehyde, okay, glyceraldehyde 3-phosphate. Alright, now if you know, fructose is a 6-carbon sugar molecule. It breaks down to 3-carbon glyceraldehyde 3-phosphate and dihydroxy acetone phosphate. And this is also a reversible reaction. Next, dihydroxy acetone phosphate gets converted to glyceraldehyde, okay, 3-phosphate. So, glycolytic pathway, which is a catabolic reaction which happens in the cell, consists of 10 steps. The first 5 steps involves where the glucose molecule consumes 2 ATP molecules to produce your glyceraldehyde 3-phosphate. Okay, so it has 5 reaction steps to produce this glyceraldehyde 3-phosphate. So let's see the remaining 5 steps of the glycolytic reaction pathway. So let's see the remaining 6 steps in the glycolytic reaction step. Why is this pathway divided into 2 phases is because the first 5 reaction involves in consumption of your ATP molecule, okay, but this set of reaction, that is from the 6th to 10th reaction, here it's completely involved in production of ATP, your NADH, your pyruvate molecules. So let's see how it goes about. So we had from step 5 glyceraldehyde 3-phosphate produced. Alright, now this glyceraldehyde gets into the 6th step where glyceraldehyde will use 1 phosphate ion plus NAD to produce your 1,3 phosphoglycerate plus your NADH plus your H plus ion. Okay, so this is also a reversible reaction, but in this step, from 6th step onwards, we will see how a glucose molecule starts generating your energy molecules. So glyceraldehyde 3-phosphate uses 1 phosphate along with your NAD to produce your 1,3-bisphosphoglycerate, your first energy molecule NADH plus H plus ions. Now the 7th step includes your 1,3-bisphosphoglycerate. Okay, first 1,3-bis phosphoglycerate plus your ADP molecule. So it takes ADP molecule, it starts producing your 3-phosphoglycerate, alright, plus 1 molecule of ATP. If you see here, we had two phosphate ions attached, so it was like 1,3-bis phosphoglycerate. Alright, it takes ATP molecule, converts that into the product released or product made was 3-phosphoglycerate plus your ATP molecule. Now this 3-phosphoglycerate gets into the next step where 3-phosphoglycerate, so again reversible reaction, forms 2-phosphoglycerate. Okay, 2-phosphoglycerate. Now this 2-phosphoglycerate, in the 9th step, it will give you phosphopyruvate, okay, phosphophenolpyruvate plus water. Alright, now this phosphophenolpyruvate takes in ADP to produce your pyruvate plus ATP. Okay, ATP. So we saw in the 6th step we have the first energy molecule produced, that is NADH. Then we also see in 7th step we are having an ATP molecule made. We also see in the 10th step again we have pyruvate and ATP molecule. Alright, so the first 5 reactions involves consumption of ATP, but the remaining 5 steps involves in the making or giving away your NADH, your ATP and your pyruvate. So the complete glycolytic reaction step consumes 2 ATP to produce 4 ATP molecule, alright, plus 2 NADH plus your 2 pyruvate molecule. Okay, this complete production of your ATP, 4 ATP molecules, 2 NADH and your 2 pyruvate is all formed by 1 glucose molecule. Okay, so 1 glucose molecule can give so many energy molecules. So this is an important reaction or pathway which happens either during cellular respiration or sometimes even anaerobic respiration, which has been found out. So I'll repeat once again, this glycolysis is also called Embden Meyerhof pathway. So please remember this. This is also called as Embden Meyerhof pathway. I hope you understood the complete pathway, which was very simplified. You can write it in 10 steps, which is very easy to remember. The most important thing is this complete pathway is made for the production of your energy molecules and also your pyruvate, which will get into your Krebs cycle. I have also explained Krebs cycle, how to remember Krebs cycle in one of my videos. Kindly have a check on that. I have taught the basic version of it. So if you want the in-depth version of your Krebs cycle or your glycolysis with structures, kindly let me know. I am willing to help you to whatever extent. So children, I hope you understood what I taught you. I hope it was easy and interesting to understand. If you have any doubts or further clarification, you can always ask me. I hope you are also viewing my other videos and stay subscribed to learn more about various things. Till then, Smart Pluto here. Bye.